Hello everyone, today I would like to share a topic that is a persistent or retained function in the Beckhoff controllers based on the TwinCAT3 system. I will introduce the two ways. One way is we code function block fb underscore write persistent data. And once you trigger this function block, it will save all the tags with the persistent properties. And the second way, I will introduce the UPS 1-second UPS function inside the CX2000 and 5000 series controllers. So as we know, in the industry controller, usually we need a retain or persistent function inside this controller, especially for some important parameters or the variables. For example, the PID, PI, D3 parameters, or valve, set point, or some recipe data inside the controller. All those data you need to retain or saved in the controller, whatever the system powered on or power up or restarted. Generally speaking, in the Siemens, Allen Bradley, or Omron system, their mainstream controller, they all have a retain function. They call it retain. So usually in the tag list or variable list, if you set the properties of this tag to retain, so that means once the system shut down and restarted, so the data will be saved still there in the controller. So usually just set the properties, that's it. But in the Beckhoff system, so we know the Beckhoff main controller, they are mainly PC-based style. So their controller is a PC with a Windows system. So how we can save or retain the data in the system. So the key terminologies in the Beckhoff controller, they call it persistent and retain function. The meanings, they are different. Unfortunately, I tested retain in the CX9000 series and the CX2000 series, but I didn't test successfully. If you call the Beckhoff technical support, maybe they will suggest or recommend you use the persistent function. So after I test the persistent function, that is the exact function what we need. So when the system restart, the data can be saved, can be retained in the system. So in the Beckhoff TwinCAT3 system, they will highly recommend we use the persistent function. So in this video, I will show two ways to persist the data in our system. For the Beckhoff mainstream controller, usually we will see the 5000, 9000, and 2000 series. So for these three mainstream series, the functions for the persistent, they are a little bit different. That's why I will mainly introduce the two ways to persist the data. So generally speaking, we do need to program a little bit, basically called the system function block. But don't worry for that. It won't cost us too much time to program. Basically, after this video, you will know how to program that, how to set your variables to be persist. So to find out this page, we can search Beckhoff information system retain and go search, and we can get to the Beckhoff information system. Or if we go to search, we can search the terminology retain or persistent. And you will find retain persistent. We will find this page. So here it introduced detailedly about the persistent and the retain. As I introduced, I didn't test successfully on the retain function. If you know how that works, please let me know. So for the persistent function, we can see the detail introduced on this area. And here it also introduced there is one important function block. It's called FB underscore write persistent data. The main series controllers, CX9000 series, 2000 series, and the 5000 series, they all support this persistent function, and they all support FB underscore write persistent data. So the main idea of this function block, that means every time when you trigger this function block, it will save all the variables. Those variables were set with persistent properties. The system will save this data. The second way, we will use the UPS function. The UPS comes from the Beckhoff system. For CX5000 controller, it already built in this UPS function. For the CX2000 series, we need to purchase one additional module that called a UPS module for the CX2000. For CX9000 series, I didn't find any information about this UPS module for the CX9000. Maybe for the CX9000, we have to use this function block FB underscore write persist data. If your system with a UPS module, you just need to call another function block. It's called a UPS function block. You do not need to trigger that. You just call that permanently. You call that function block. So with this UPS function, when the system shut down the power at the last 1 second, it will save this data, save these variables with persistent properties. It will save your tags and variables in the non-volatile RAM in your system. So that is two ways. Okay, so let's start from the first way. We called function block FB underscore write persist data function block. Before this video, I already finished that test and used the actual controller to test that function. So that time I archived that project. I saved that project and zip it as a TN-zip file. So usually it's highly recommend every time you finish one project, at the end of the day, it's highly recommend you archive that project. Once you archive that project, it will go to one TN-zip file, so that is easy for you to backup in your memory stick or to backup in the Dropbox or global server. So to open this zip file, we go to File, Open, and click this Open Solution from Archive. So I open this archive file, open, select the one directory you want to open this project. Select the one directory you want to deploy this project and select. It will unzip this project. In this video, I only introduced the detail how we set up the PLC project, how we create the solutions. If you want to see those details, you can review my previous videos. I introduced how we can create a project, how we set up the PLC project. So this project, I already tested that function. So I will mainly introduce, quickly review all the important settings. Because we are going to call this a function block named FB underscore write persist data. So I will copy this name because this function block comes from the system library. So we need to call the system library first. So we expand the PLC project, go to the reference. And from here, we click this add library. And from here, search function block. So wait for a couple of seconds. It will pop up. This is a FB underscore write persist data. Click OK. The system will add that library. After this, under the global variable list folder, we click add a global variable list. So I renamed this global list as a global variable list GVL_P persistent. So under this global list, I create two tags. That is a two integers value. So the first one, I data 1, I data 2, second one. So they are integer value. But take care here, if by default, the global variable, if you open here, that by default, that named variable underscore global, right here. To set your system to be persistent or to be saved, you must announce this. You must claim this terminals here. Persistent. You must manually type in this persistent. That means if you declare your data within this area, this data will be retained or will be saved. You could create a lot of data. That data you need to be saved here. After you declare the variable within this persistent area, so we shift to the POU, your program area. So we can create one program here. You can right click, press add, and press POU. And from here, we select program. We select program. So in my system, I name it POU_persistent. That means all the persistent function block, I program them under this program as a structured test. Click the open. So after this, it will create a POU_persistent. Under this program, we will create an instance of that function block. So from here, we claimed our instance tag FB write persistent data. You can rename by you want, but here we need to call this function block FB_write persistent data. Other than this, we also need to create a one bool tag. I called it a bool B persist write WR. And from here, you can type in this. So to type in, right click, click this input assistant. So we can search your function block, FB_write persistent, okay, here, and click the OK. So it will automatically show up all this input and output. And from here, this is that function block name. So we rename this area. I will copy this, right click, or copy, and paste here. After this, we need to type in this port name, this port number. In my system, that is 851. To find out the port number, you can go to your PLC properties, double-click your PLC project, and it will show the port number here. So usually, by default, that is 851. So you type in this port number, and on the start, for the start input, we use this tag B persistent write, and we could leave others for empty. And at the bottom of this function block call, we will force give a 0 to this tag. That means usually we can put on this tag connect one button on your HMI. Use the HMI button to trigger this tag, or just set a 1 to this tag. Because every time when the tag get 1, got a trigger, the system will use this function block, write the data into the non-volatile RAM area. So all the variables with persistent properties, so those data value will be saved in your system. You will see one special file under the TwinCAT3 folder somewhere. So after we finish the POU, this program, so we need to go back to our main. Let's call this a program. So to call this program, we just type in and make a bracket here. So after this, the system will call this program. So basically, we finished the first way for the program to persist our data. Let me show a video when I used the actual controller to do this task. So this is the system port. So we can from here to change this port number. And don't forget, click this auto start boot project. So the system will automatically boot your project. And go to the system, select this run mode, automatic boot to a run mode. So from here, we download the hardware configuration. It's called active configuration. So let's log in the program. So now the program already downloaded into the controller. So we go to PLC window, watch number 1. So in this watch list, we can write the data to compare the variable with and without this persistent properties. In the normal global list, I have a data named I data underscore normal. So this tag doesn't have a persistent properties. It doesn't have a persistent setting. In the global underscore p, this variable list, we set 2 tags here. So that's why when we call that, it named gvl underscore p dot I data 1, I data 2. Rename it data 2. So from here, we type in the value. The first data I gave 230, second value I gave the 430, and for the normal value, I gave the 770. So now we set this bool tag write persistent value set 1 time. So at that time, when I set 1, so the system will write idata1 and idata2 value into the system. So from this step, I will shut down the power. So we can see the system is shut down. So we lost the communication. And let's see when the system restarted. Let's check out the values in these variables. So let's wait for a couple of seconds, waiting for the communication recover. So currently we can see that CX-14D8A6 that shows error. That means we lost the communication. The system is restarted. Now the system restarted. So we can see the value with the persistent properties, all values are saved there. So that is the first way we code function block named FB underscore write persistent data function block. And we need to trigger this function block instant. And every time we trigger that, all the tags with persistent properties, they will be saved. Once you shut down the power or you restart your controller, those data won't be lost because all those variables, all those data are saved in a special folders, in a special files inside the CX controllers. The second way to save the data, we will use the UPS inside the CX controller. As I know, the CX5000 series, they all build in the UPS. For the mainstream CX2000 series, you can purchase one add-on module. They called 1 second UPS module. So if we type in UPS modules for CX2000, you will find this information page. So under the embedded PC, under the CX2000 folder, and under this hierarchy power supply unit, you will find this module here. So this module named power supply unit and UPS modules for CX2000. You need to specially purchase this module. So those modules supply the UPS function to your CX2000 controller. Allows your system to save the data in the last 1 second, but you also need to program the one function block, allow to your controller and this UPS module to communicate with each other. So that function block named FB_S UPS. When the system shut down, your UPS and your controller will communicate with each other. We can see this function block mode. So if you select write persistent data shut down, that means so at the last 1 second with this UPS function, the system will write the persistent data to your system. So this function block will allow all the persistent data saved in your system. And usually, I highly recommend when you call this function, we can also call another function block named nt_shutdown. That means usually on the HMI, if you want to restart your system, we'd better call that function block to restart the controller. And at that moment, when the system shut down, so the controller and UPS, they will communicate with each other at the last 1 second. So the system will archive the data, save the data. If we go here, you can search NT shutdown. So the second way, we will call the FB_S_UPS function block, system function block, as well as we called NT_shutdown. Other than this two function block, keep in mind we still need a 1 second UPS module for the CX2000 series controller. For the CX5000 controller, they all built in this UPS module. As shown on the screen, so we call this instant function block FB_NT_shutdown. And we create one bool shutdown required button, shutdown required bool here. Under this, we called function block PS_UPS, and we type in the PLC port number 581. That's the PLC port number I shown before. And this is a UPS port number. That's by default is usually this number. And UPS mode, I type in this, take care of this persistent mode. Use this format, ES UPS. This, you can find out the information from this function block help. So here has an example here. After that, same way, we log in the program and we go online and we type in the value. So this time I type in the data 1, 323, data 2, 444. So this time I won't trigger the function write persistent data, that bool, I won't trigger that. So this function block will continuously be called. we do not need to trigger anything unless you want to correctly shut down your controller. So you can trigger this bit, shut down, require this tag. So once you trigger this bit, it will shut down your CS controller NT system. After I trigger this tag, so the system is restarted in 2 or 3 seconds. So at that moment, we can see the communication here. It shows red. That short moment, the TwinCAT3 lost the communication with a controller. And after the controller recovered, so after the system recovered, you can see the data is still here. So that means with the second wave, controller plus the UPS, they communicate with each other. And the last 1 second, the system will supplied by the UPS to save the data into a non-volatile memory. So we can see all those data are saved here. So to do a summary, in the CS controller system, so to save your data when the system shut down, so basically we will have 2 ways. One way is we call the function block and trigger the start on this function block. So every time you trigger, the data will be saved into a special memory in the system. And the second way, we can use the UPS module in the CS controller, and also we need to call this UPS function block. With this UPS function block, you do not need to trigger that. The controller and the UPS module will automatically save your data into the non-volatile memory. You do not need to specially trigger this function block. So basically, there are 2 ways. Personally, I will prefer the first way. We call the write persistent data. You do not need to purchase additional money for that UPS module, but you need one global button on the HMI, for example, named save data or write the parameter, something like that. Every time an operator type in the important data, for example, the recipes or the valve settings, at the right corner, you can put a very big button, say write the data or save the data. So that button can connect this be persistent WR tag. So once that turned on, that moment the system will write the important data into this non-volatile memory area. So that's it for today.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe. See you in next video.